Alright, let's go. Number 10. The Nebra Sky Disk, the oldest realistic depiction of the cosmos. In 1999, illegal treasure hunters near Nebra in Saxony-Anhalt, Germany, unearthed a bronze disk approximately 30 centimeters in diameter. It passed through a network of black market dealers before archaeologist Harold Meller tracked it down in a sting operation in Basel, Switzerland in 2002 and seized it for the German state. The disk dated to approximately 1600 BCE. It is covered in gold inlays, a crescent moon, a full sun or full moon, a cluster of 7 dots, corresponding precisely to the Pleiades as they appeared over Central Europe in 1600 BCE, 2 arc strips along the edges, and a lower arc called the horizon boat. It is the oldest known realistic depiction of the cosmos. Nothing like it exists from the same period anywhere in the world. But here is where this stops being a decorative artifact. The 2 horizon arcs are not decorative approximations. They are measurements. Their angles correspond precisely to the difference between the summer and winter solstice sunrise positions at 51 degrees north latitude, the exact latitude of Nebra. Someone in Bronze Age Germany measured the annual range of sunrise and sunset positions with sufficient precision to encode them in gold on a bronze disk to within a degree of accuracy. This required systematic multi-year astronomical observation and the mathematical skill to translate those observations into physical angles. The Nebra Sky Disk is, in functional terms, a calendar instrument. The society that made it left no other written record of having done any of this. The disk is in the State Museum of Prehistory in Halle, Germany. The gold is original. The measurements are confirmed. The treasure hunters who found it sold it for approximately 30,000 Deutschmarks. Number 9. The Göbekli Circle, the Solar Observatory. In 1991, aerial photography of agricultural land near Göbekli in Saxony-Anhalt revealed crop marks indicating a buried circular structure. Excavation confirmed it, a circular enclosure approximately 75 meters in diameter with a central mound, a ditch, and 2 palisade rings with specific gateway openings. It dated to approximately 4,900 BCE, predating Stonehenge by 2,000 years. The gateway openings were not random. The 2 southern gateways align precisely with the sunrise and sunset positions on the winter solstice at the latitude of Göbekli. An observer standing at the center on the winter solstice would watch the sun rise through one gateway and set through the other. But here is where this overturns the standard chronology. 4,900 BCE is the early Neolithic in Central Europe, a period when the standard model places regional populations at a subsistence farming level without the social complexity for systematic astronomical observation. Göbekli says otherwise. Identifying the precise solstice required multi-year observation of sunrise and sunset positions. Encoding those positions in a 75-meter monument required surveying skill. And building the monument required organized, collective labor. All of this was happening in Central Europe nearly 7,000 years ago. The Göbekli Circle has been reconstructed at the original site and is open to visitors. On the winter solstice each year, the sun still rises and sets through the original gateway alignments. The observation was correct. The people who made it knew exactly what they were doing. Number 8. Newgrange, the alignment that works for exactly 17 minutes. In County Meath, Ireland, there is a passage tomb dating to approximately 3200 BCE. Older than Stonehenge, older than the Great Pyramid. The mound covers approximately 1 acre and contains a 19-meter passage leading to a central chamber. Above the passage entrance is a small rectangular aperture called a roof box, whose purpose was not understood until archaeologist Michael O'Kelly made a critical observation in 1967. On the winter solstice, and only on the winter solstice, at sunrise, a beam of sunlight enters through the roof box, travels the full 19-meter passage, and illuminates the floor of the central chamber for approximately 17 minutes. On any other day of the year, the passage floor remains dark. But here is where the engineering precision becomes genuinely astonishing. The roof box was constructed at the exact height and angle required to emit sunlight only when the sun is at its lowest declination, the winter solstice sunrise. Surveyors using modern instruments have confirmed the alignment to within a fraction of a degree. Newgrange was built with 200,000 tons of material, without metal tools and without wheeled transport, in 3200 BCE. The people who built it identified the exact angle of the winter solstice sunrise through observation. They translated that angle into a physical aperture positioned at the top of a stone passageway with an accuracy that a modern architect with GPS would consider a competent survey. And they achieved it with wooden stakes and rope in the sky. The passage is illuminated every winter solstice for 17 minutes. A lottery system now manages access. There are thousands of applicants for a handful of places each year. What those people see is exactly what the builders intended 5,200 years ago. Number 7. The Maya Venus Table. Accurate to 2 hours over 104 years. The Dresden Codex is one of 4 surviving Maya books, dating to approximately the 11th or 12th century CE and held in the Saxon State Library in Dresden since 1739. Pages 24 through 29 contain the Venus Table, a series of calculations tracking the synodic cycle of Venus, meaning the period between successive appearances of Venus as morning star. The Venus synodic cycle, as measured by modern astronomy, is 583.92 days. The Maya Venus Table uses a base period of 584 days. The accumulated error in the Maya calculation over the full 104-year Great Cycle tracked in the table is approximately 2 hours. A Venus calendar with a 2-hour error over 104 years, built using naked eye observation, without telescopes, without calculus. But here is where this requires full attention. The Dresden Codex was written in the 11th century CE, but the astronomical tradition it documents was not developed then. The earliest Maya astronomical inscriptions date to approximately 200 BCE, and the observation tradition behind them predates that by centuries. The Venus Table represents the product of institutional astronomy, a tradition of observation and record-keeping maintained across hundreds of years, with each generation's measurements corrected against the accumulated records of previous generations. 4 Maya books survived the conquest. Bishop Diego de Landa burned every Maya book he could find in 1562, calling them works of the devil. The Venus Table, representing centuries of accumulated astronomical observation, survived in one of the 4 books that escaped the fire. Number 6. Stonehenge, the monument that predicts eclipses. In 1963, engineer Gerald Hawkins published an analysis in Nature proposing that Stonehenge could be used to predict solar and lunar eclipses using the 56 Aubrey holes, a circle of pits around the outer edge of the monument, as a counting device. Moving a marker around the holes at a rate of 3 per year, a user could predict eclipses with high accuracy. Eclipse prediction requires knowledge of 3 astronomical cycles: the solar year, the lunar month, and the nodal cycle of the moon, the approximately 18.6-year cycle that determines when eclipses can occur. The nodal cycle cannot be identified in a single observation. It requires tracking the moon's behavior over at least one complete 18.6-year cycle. But here is where the technical requirement becomes the story. To encode eclipse prediction capability into Stonehenge's architecture, the builders needed to have tracked the moon's nodal cycle across multiple human generations before the monument was built. The monument encodes the result of that observation. The observation itself required an organizational infrastructure, institutional, multi-generational, sustained, that predates the physical construction of Stonehenge by decades or centuries. Stonehenge began construction in approximately 3000 BCE. The eclipse prediction capability encoded in it was not the spontaneous achievement of a single inspired builder. It was the product of a sustained observational program conducted by people who left no written records of having done it, and who built the results into stone that has been standing for 5,000 years. Number 5. Chichen Itza, the shadow serpent that has worked for 1,000 years. The Pyramid of El Castillo at Chichen Itza in the Yucatan Peninsula dates to approximately 900 to 1000 CE. It is 30 meters tall, with 4 stairways of 91 steps each, totaling 364 steps plus the top platform, equaling 365. On the spring and autumn equinoxes, at a specific time of the afternoon, shadows from the terraced corners of the pyramid create the appearance of a feathered serpent descending the northern staircase. Diamond-shaped shadow triangles aligning with carved serpent panels on the balustrade and connecting to the stone serpent head at the base. The event lasts approximately 45 minutes. It occurs twice per year. It has been occurring for approximately 1,000 years. But here is what the precision required actually means. The shadow pattern depends simultaneously on the angle of the equinox sun, the specific height and angle of each terrace, the pyramid's orientation relative to true north, and the height of the balustrade. Changing any one of these parameters by a small amount destroys the visual effect. The architects calculated all of these parameters simultaneously and built them into a 30-meter stone structure with sufficient accuracy that the effect has functioned continuously for a millennium. This is precision architectural astronomy. The deliberate encoding of a specific astronomical event into a permanent monument, requiring calculations we do not know how the architects performed, achieved with an accuracy that has not degraded in 1,000 years. The shadow serpent still descends, every equinox, on schedule. The architects did not sign their work. Number 4. The Antikythera Mechanism. Eclipse prediction in 70 BCE. The Antikythera Mechanism, recovered from a Roman shipwreck dated to approximately 70 to 60 BCE, tracked the Metonic cycle, the 19-year cycle after which lunar phases repeat on the same calendar dates, and the Saros cycle, the 18-year cycle used for eclipse prediction. It predicted eclipses by date, month, and hour. Its eclipse prediction function has been confirmed accurate against modern calculations. Encoding the Saros and Metonic cycles in a mechanical gear train required designing a specific gear ratio corresponding to the mathematical relationship between the two cycles. The gear ratio used, 254 to 19, is the exact ratio needed. The gear train required manufacturing precision not matched in European clockmaking until approximately the 14th century CE. But here is the gap that demands attention. The mechanism was built in the 1st or 2nd century BCE. The next known mechanical device of comparable complexity does not appear in the European record until 1,400 years later. What existed in the intervening 1,400 years is unknown. The mechanism is the only surviving example of its type. Instruments of this sophistication are not invented once and never repeated. If this one exists, others almost certainly did. None have survived. None are documented. The mechanism is in the National Archaeological Museum in Athens. The gear train that predicts eclipses is intact. The tradition that produced it has left no other trace. Number 3. Nebra Playa, the nomads who built an observatory in the Sahara. In 6000 BCE, in 1974, archaeologists crossing the Egyptian Sahara found an ancient lakebed called Nebra Playa, approximately 100 kilometers west of Abu Simbel. During the African humid period, when increased rainfall made the Sahara habitable between approximately 11,000 and 5,000 years ago, nomadic cattle herders visited the site seasonally and built stone structures, cattle burials, and a stone circle dated to approximately 4,500 to 6,000 BCE. The stone circle is older than Stonehenge, older than the pyramids. Its alignments track the summer solstice sunrise and specific star positions of the period. Astronomer Thomas Brophy's 2002 analysis proposed that 6 of the circle's stones correspond to the 6 brightest stars of Orion's belt and shoulders, with their relative positions in the circle accurately representing those stars' positions in the sky during the monument's construction period. But here is where the analysis produces a result that has not been resolved. Brophy further argued that the distances between the stones, interpreted as a scale model, correspond to the actual physical distances between Earth and the stars being represented. Not their apparent positions on the celestial sphere, but their three-dimensional distances in space. If correct, nomadic cattle herders in the Sahara were encoding stellar distance information 6,500 years ago using a methodology that should not have existed. The mainstream response is coincidence. Brophy disputes this. The debate is ongoing. The basic solar alignments at Nebra Playa are confirmed regardless. They were made by nomads with no cities, no writing, and no civilization in the conventional sense, who built an astronomically aligned monument that predates most structures we associate with organized astronomical observation by thousands of years. Number 2. The Dogon in Sirius B, the star that shouldn't have been known. The Dogon people of Mali maintained an oral cosmological tradition that French anthropologists Marcel Griaule and Germain Dieterlen documented in fieldwork conducted between 1931 and 1952, published in the journal Sudan in 1950. The Dogon tradition included descriptions of a companion star to Sirius, a small, extremely dense star completing an orbit around the main star every 50 years, made of material heavier than any substance on Earth. Sirius B, the white dwarf companion of Sirius, has a confirmed orbital period of approximately 50 years. White dwarfs are among the densest matter in the universe outside of neutron stars and black holes. These specific characteristics were not publicly documented until the 20th century, but here is where the account becomes genuinely contested rather than simply remarkable. The standard skeptical explanation is that Griaule's fieldwork methodology led Dogon informants to incorporate European astronomical information into their responses, that the correspondence reflects post-contact data contamination rather than pre-contact knowledge. Griaule's methodology has been criticized by subsequent anthropologists. The alternative explanation is that the correspondence reflects genuine pre-contact astronomical knowledge of an object invisible to the naked eye. Neither explanation is fully satisfying with the evidence available. What is documented? Griaule recorded a cosmological tradition, including specific descriptions of a stellar companion with specific orbital and physical properties. Those properties correspond to the documented properties of Sirius B. The fieldwork began in 1931. The specific density and orbital characteristics of Sirius B were not common public knowledge in 1931. The debate about what this means has been running for 70 years and has not produced a consensus. Number 1. The 26,000-year cycle, precession encoded in Saharan stones, before history began. The precession of the equinoxes is the slow wobble of Earth's rotational axis that shifts the positions of the celestial poles and equinoxes against the background of stars. The full cycle takes approximately 25,772 years. It means that the North Star changes over millennia, currently Polaris, but Thuban in the constellation Draco 5,000 years ago, and Vega 12,000 years from now. Precession was formally documented in the Western astronomical tradition by Hipparchus of Nicaea in approximately 127 BCE, who detected it by comparing his star position measurements against those of Timacharis made 150 years earlier. The discovery required measurements spanning 150 years and rigorous mathematical analysis. Thomas Brophy's analysis of Nabta Playa proposed that the circle encodes knowledge of precession, specifically that the star map it contains depicts the positions of Orion's stars, not as they appeared at the time of construction, but at specific points in the precessional cycle going back to approximately 16,500 BCE. If correct, the builders of Nabta Playa were tracking a 26,000-year astronomical cycle, 6 millennia before Hipparchus formally discovered it. But here is where all 10 entries in this video converge on a single question. The documented history of astronomy tells a clear story. Systematic astronomy began with the Babylonians, was refined by the Greeks, transmitted through the Islamic world, and reached modern form through the European scientific revolution. This story is supported by extensive documentation and is not wrong. What all 10 entries collectively suggest is that this documented tradition was preceded by an undocumented one. Solar calendar precision in 4900 BCE, Germany. Eclipse prediction capability in 3000 BCE, Britain. Venus cycle accuracy to 2 hours across 104 years. Possibly precessional knowledge in the Sahara 6,000 years before Hipparchus. None of it was written down in recoverable form. All of it is inferred from the physical alignments encoded in structures that are still standing. The inference is sound. The alignments are real. The measurements are confirmed. The astronomical events they predict still occur on schedule. That undocumented tradition existed. These monuments are its physical residue. The people who built them watched the same sky we look at tonight. tracked it across generations with sufficient precision to encode it in stone, and left their instruments standing for anyone who knew how to read them. We are still learning how to read them. 10 astronomical achievements across 10,000 years of skywatching before the invention of writing. The Nebra Sky Disk with precisely measured solstice arc angles. The Göbekli Circle aligning its gateways to the winter solstice in 4900 BCE. Newgrange illuminating its inner chamber for exactly 17 minutes every solstice since 3200 BCE. The Maya Venus table, accurate to 2 hours over 104 years. Stonehenge encoding eclipse prediction in its 56 Aubrey holes. Chichen Itza producing its shadow serpent on every equinox for 1,000 years. The Antikythera Mechanism predicting eclipses 1,400 years ahead of European clockmaking. Nabta Playa encoding a star map built by nomads. The Dogon tradition describing Sirius B before its properties were publicly known. And possibly, the 26,000-year precessional cycle encoded in Saharan stones 6 millennia before Hipparchus. The sky has not changed. The winter solstice sunrise still enters Newgrange through the roof box for 17 minutes. The equinox shadow still descends the staircase at Chichen Itza. The Venus cycle still runs at 583.92 days. All of these events are happening right now, on schedule, as they have been since before any of the structures that track them were built. The sky is the same sky. The people who watched it with sufficient attention to build precision instruments around it are gone. What they knew about it, we are still reconstructing from the angles they cut in stone. If you want to see more videos like this, click the video on screen now and make sure to subscribe.